Hello, everyone. Thank you so much for joining today's webinar session on Deception Defense, our North Korean threat actors targeting your bank. It's my absolute pleasure to have with me Sahir Hidayatullah, CEO of our partner Smokescreen. And this is myself, Maruf Ahmed, the Global Director of Technology and Services at One World. With Sahir, there isn't much interaction to given to him. He's already very well known in the market, in the cybersecurity industry, and featured in the Fortune magazine, and also a serial cybersecurity entrepreneur. And most importantly, he is the CEO and the mind behind the Smokescreen, the leading deception technology vendor. So in today's webinar, we are focusing on deception defense, and with the focus on currently what is happening in the industry is that what many of you already have known from being the banking sector or financial sector, that Bangladesh Bank has recently issued a notice to all banks to take extra security measures, which is happened after the release of a rare joint advisory alert from on the North Korean cyber threat by the US Department of State, Homeland Security, and the FBI, that North Korea has resumed targeting banks in multiple countries, and they're initiating the fraudulent international money transfer and ATM cash outs by targeting ATM networks and SWIFT systems. And again, this is not very new because unfortunately we had that infamous Bangladesh Bank heist where we had the North Korean threat actors had targeted Bangladesh before. And now I'm going to turn over to Sahir to talk about what are we seeing, what are the things to be done in this current circumstances. Over to you, Sahir.
Thanks for having me, Maruf. It's always a pleasure to be back and looking forward to the conversation today. I do urge all of you to make liberal use of the question box, because it's always nice to not have one person talking endlessly through the conversation. So, any questions that you have as we go through the presentation, I think it would be great if we could have those, and we'll save ample time to make sure that we use your, use your questions and answer them well. So, to Maruf's point, Smokescreen has been seeing this uptick in targeted attacks by various threat groups. Today, we're going to focus on the modus operandi of one of those threat groups. And over the course of the next 60 minutes, we're going to talk about a few things. I'm going to start with a bit of an introduction to the problem statement. I won't spend too much time here because, I think pretty much everyone who's on the webinar today is sort of aware of what the threat vector is. I'm going to go into more specific detail. To do that, I'm also going to introduce the concept of how you can detect these attacks. So using what is known as deception technology, we have very successfully detected and worked on a number of heists around both ATMs and SWIFT transaction fraud, which has happened through hacking. So I'm going to talk about how we've done that and briefly what deception is. The bulk of our time today is going to go through the anatomy of a hack by the so-called Beagle Boys group. Now, depending on who you speak to, Beagle Boys is a subset of the Lazarus group. There are different names depending on which vendor is actually tracking the threat actor. But essentially, there's a common theme to this threat actor. And while obviously their entire methodology is not something we can cover in 60 minutes, I've tried to break up the kill chain from the perspective of how they operate, how they actually go through your network, right from external compromise to internal. And I'm going to try to give some examples of that. And then obviously, finally, we'll spend a decent amount of time on Q&A. So that's the broad flow for today. Just to start off with, I think it's important for us to understand why these attackers operate the way they do. They typically are focused on the idea of one of two sort of actions and objectives. And that is either they want to compromise the ATM system to infect the financial switch. They have the ability to load and inject malicious code into the financial switch, be it on Windows or be it on a Unix platform, with the goal of authorizing certain card transactions that are obviously cards that they control. That's option one. Option two that they go for is the SWIFT hack that has become quite infamous. And in both these cases, the really interesting thing is about 60 to 70% of their methodology syncs up with the methodology used by most APT groups today to traverse the kill chain. And one of the key things I wanted to touch upon today was what that kill chain looks like. Also, for those of you who are doing red team assessments, it means that you can try and simulate these particular kill chains in your bank, in your environment, to test your own ability to detect and respond. Obviously, I'm going to use the concept of deception. And the reason I'm going to use deception is, I'm going to sort of talk about in the next slide. So, you're seeing this slide with a bunch of rocks here. Imagine, that this just looks like the landscape for a bad guy. But what the bad guy doesn't see is hiding behind the rocks, there's a soldier pointing a rifle at him. Now, when you deal with very advanced and sophisticated threat groups, your ability to just detect them with your regular security controls is extremely limited. The reason for that is these guys have their modus operandi down to a fine art. They are typically very well conversant with traditional security controls, defensive controls, obviously your firewall, your antivirus, and some of your other controls. I'll talk about how they evade some of these. But the reason behind deception is we want to fight back. So we want to actually make this environment harder for them to compromise. And the genesis and origin of deception technology comes from offensive security. So the guys who are actually really good at offensive security and red teaming are the folks who typically mandate and recommend deception technology, because it makes life very difficult for the bad guy, as we'll see. So let's just talk a bit about the problem today. What tends to happen is we have, something we want to protect, in our case, some money, hopefully. And, the threat group is going to come in, and the threat group is going to want to try to get to that pot of gold. So what we've done is we've put in place some barriers. These are our preventive controls. This could be, for example, some sandboxing technology. It could be antivirus. It could be your firewall. We may have put in some monitoring. So we may have got the equivalent of a CCTV in the sense of an IDS, IPS, maybe, some endpoint protection controls. And, finally, we've probably got some monitoring. So somebody actually monitoring the results of these either through a SOC or a SIM. Now, the interesting thing is every single organization that has been breached has had these controls, which implies that, plus minus, right? Maybe they've had some, maybe they've not had all, but at a minimum, everyone has had a firewall and an antivirus. So preventive controls don't work. And the reason for that is that the threat group is able to predict what they're actually going to encounter. They already have their bypasses for these different controls. And so because the environment is predictable to them, they are able to bypass the security controls, remain undetected, and finally reach the pot of gold. So this is a real problem for us, because what it means is all the list of things that we keep trying to do in security, there's already, these guys are already one step ahead of us. They know to expect an EDR. They know to expect a SOC and a SIM and a monitoring system. They know to expect an IDS IPS. They know to expect a WAF, right? So what do we really do with this problem? So the way we sort of try to deal with this from a deception approach, for those of you who are familiar with honeypots, the only difference between honeypots and deception is honeypots were more sort of for research purposes. Deception is for threat detection. And that means it's honeypots done at scale, and it's done throughout the kill chain. So what we do with deception is we layer the entire environment, every single pathway, every single route that the threat actor is going to take. We layer it with what we call decoys. Decoys don't necessarily mean fake computers. That's your traditional notion of a honeypot. It could be fake data. It could be a fake ISO message, right? For an ATM. It could be fake network traffic. It could be fake security software. Pretty much anything that the bad guy is expecting to encounter on his journey, deception creates honeypots out of that. It creates honeypots of your Swift servers, of your ATM systems, your financial switch systems, etc. And the goal is, when the bad guy comes into the network, we want to give him a really, really wide landscape of targets which he can actually access. The problem is only one of these pots of gold is real. Maybe the Swift server is one of these pots of gold, but the hacker is seeing 20, 30 of these and all sorts of juicy things that he can pick up. But how does he know which is real? the deception is such that if he even tries to guess or fingerprint or find what is deceptive, he's going to be detected, and the alert is going to be raised. So if you put yourself in the mind of the bad guy, what path are you going to take through this environment? The problem is that it's become very difficult. We have shifted the cost and burden of remaining undetected onto the bad guy. In the previous slide, the burden of detecting him was ours. We had to work very hard. So the idea of deception is to create an active defense against these new targeted threat groups, where we are going to feed them information in the network that they think is valuable. And the second they try to use that information, bam, we've got them. And the interesting thing about that, if you just consider for a second that we remove every other security control. So let's imagine we have nothing else, right? You see that this is still a viable strategy, because the threat group is still not able to understand where they can go, what information they can use, what systems to target, etc. Anything can be a decoy. And as we go through the kill chain, you'll realize the depth that with this goes through. So it's not just a question of, okay, you've got 5 Swift servers, we create 10 Swift servers. No, across the kill chain, right from before they even enter your bank, we are going to be talking about deceiving them, right? So that's sort of how deception kind of works. And to kind of hone in on this point, there are different types of decoys. You have decoys which go on the network layer. So these are your traditional, honeypot servers, applications, your Swift application, a database server, an ATM system, whatever type of network asset you may have. So we create decoys of those. The second is on the endpoint side. So on the endpoint side, there's a whole lot of deception you can do on your real endpoints, like your laptops, which you're all currently using. So we can create decoy files, passwords, fake Swift credentials, fake pointers to different applications, fake logins to ATM systems, etc. So we can really create a network of fake things on the endpoints themselves. Many of you may already be aware that a lot of the attacks originate from the endpoint because they happen through a user getting some malware. In fact, when you talk specifically about the Beagle Boys group, they have 2 attack vectors that they tend to rely on. They rely on either spear phishing or watering hole attacks in order to get malware on a user's desktop. So, spear phishing, I think everyone would know what it is. Watering hole attacks are, they will infect and compromise a site, which basically, banking users would go to, and then they serve malware from that site. The end goal is to get the user's endpoint infected. So that becomes their initial breach vector, right? And the interesting thing is there's some indication that they are outsourcing this initial access. It's not something that they really want to focus on. They want to focus more on the next pieces of the kill chain. So there's some indications that they are relying on other, less significant threat groups to actually deal with this initial access by getting the malware on in the first place. What does this mean for you? It means that every commodity malware infection that you find in your network is something that could convert into something much more horrific if you don't act on it. So that's something to bear in mind. What could have seemed like a commodity malware infection might be sold on the dark web, and that access is sold to these threat groups, and they're actually able to use that access. So that's why the endpoint becomes crucial when we actually try to place deception. We also place stuff on the cloud. When we speak specifically about North Korean threat groups, we haven't seen much activity in terms of their attack on cloud environments. I think this is primarily because their final objective are not cloud-based systems. You do have cloud-hosted, applications for Swift, etc. But it's not been the largest target. A lot of folks have stuff in-house. So, we've not really seen much in terms of activity there. And the last place where you'll see a lot of activity is in the use of Active Directory. So Active Directory is the phone book of the network for an advanced threat group. I don't need to scan your network. If I can just literally query the directory, I can make one LDAP query and I can download who are all the users, where are they located. Probably if you go look at your Active Directory, you may even have a OU or a group which says Swift users. That makes it very easy for me to find who are the people, where are they located, find which systems they use, etc., etc. So this allows them to do a lot of internal reconnaissance once they get a foothold. In fact, I would go so far as to say, if there are any of you who have not done a security audit of your Active Directory recently, you must very seriously consider this, because this is one place again where the commonality between threat groups comes out. They leverage Active Directory to gain what is called domain dominance of the Active Directory domain, and from there the keys to the kingdom are with them. So, we've talked about the sort of the three major estates, removing cloud, where the bad guys operate, and you need to think about your protection and detection strategy across all three: at the network layer, at the endpoint layer, and in the Active Directory layer, right?
So,
So, yeah. Sorry, Maruf, I think you had a question.
no, so this is I think just to add perhaps is that I think since you very well said about explain the type of decoys, and I think if perhaps it would be also helpful to understand for our audience is that this is a very interesting fact is that what is happening in the attacker's perspective, because right now on the defense perspective what we are doing is, if you're a defender, you are obviously able to identify and stop thousands of potential threats and being victimized if you're all wrong even once. Now this same tactical disadvantage is transferred to the attacker when the deception is uh, laid in the network, and with so many different categories of deception, decoys, types of deception that Sahir has mentioned, because this attacker is faced with so many different types of deception to play with. So the playing with the odds, don't you agree, Sahir?
Yeah, Maruf, absolutely right. This is what was commonly known as the defender's dilemma. So the defender's dilemma is that, as Maruf rightly said, as defenders, we have to be right 100 times out of 100, 24 by 7, 365 days a year. The second we are wrong even once, or we miss something, it's game over. So we've always got to be right. So that doesn't make us feel very good, right? That defender's dilemma. What deception allows you to do is to create the attacker's dilemma, where the attacker has to be right 100% of the time, which means that when the attacker is going through the network, even one detection that comes out to the security team, and the whole tables are turned in favor of the bank or the defense, right? So with deception, what happens is the bad guy has to be right throughout the kill chain, whether that kill chain takes weeks or months. Every single system he touches, every credential, every file, every bit of network traffic he sniffs, every application he exploits, every user he targets, he has to be right 100% of the time. So the switch, as you very rightly pointed out, Maru, from the defender's dilemma, where we have to be right, we transfer that onto him, and the attacker has the dilemma. That's a really powerful and crucial concept to understand. And that's only really possible with any type of active defense solution. Threat hunting could be another way that you look at that, but primarily deception and honeypots is a great way to create and increase the attacker's dilemma. A great way to see this is call your penetration testing teams, give them a scenario where there's deception, and just see. We've actually measured this, and we found that they even started second guessing the real systems. They would try to connect to a real system, and then they'd say, must be a honeypot, let me back off. They would find a real password, and they would say, no, 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 I'm quite sure this one must be fake. So they actually got more frustrated, and because they were so worried about being wrong, because even one signal, deception systems are very low false positive. Anybody touches a decoy, it means you have to investigate it. So the attackers become very, very cautious, and they really, really have a hard time. So definitely very valid point, Maru.
Thank you, Sahir.
So let's take a little bit of an example. So we've talked a little bit about what's deception. I want to talk a bit about how this threat group operates. And the way I'm going to do that is I'm going to take you through sort of an anatomy of an attack, right? I'm going to try to show you the different phases of the attack through demonstration of how they will operate in this environment, right? So we're going to start right at the top with their initial access. Now, I spoke about one way that they get initial access, and that was that they essentially buy their way in through commodity malware, or they infect through spear phishing, right? So this is an attack vector that we have to deal with, but essentially getting to zero malware in an organization may be somewhat hard. The second very common attack vector, which is being exploited right now, is exploiting web applications and remote access services and systems like your Citrix servers, like your Pulse Secure VPN. There's a lot of VPN systems right now that have actually had vulnerabilities post-COVID. And the reason that there's an uptick in the attempts to access through this route is simply because all the users suddenly have gone remote. In the old days, this wasn't a very useful, it was a useful strategy. The China Chopper group used to be very good with their web shells. But now the threat groups are taking this because all your users are working remotely. They're connecting to these web applications. You may have had to expose them very last minute. They're connecting to VPNs. So suddenly, if I just steal one user's credential, by phishing him, I can then find your VPN, log in, and I'm in your network. I'm connected to your network from the comfort of my home. So I'm going to show you, sort of how this process would look a little bit. And to do that, I'm just going to pop over to, my terminal over here, and I'm going to just make things a little bit bigger. So what I'm doing here is I have a fake bank or company that we're going to target called MaxCorp. MaxCorp's domain is maxcorp.tech. And what I'm going to do is I'm going to do a DNS reconnaissance. So what that means is I'm actually going to scan for any of these types of systems for MaxCorp. And these are all interesting systems to me because SSL VPN, dev systems, Citrix servers, etc. Right? So that's what I'm going to try to do. Let me just try to actually run that scan. And you'll see that, I've got pretty fast results from this subdomain enumeration. This is exactly how an attacker will operate. This is how they're finding stuff. I would urge you to try this against your own environments. You can also go to a site called crt.sh and you can try it. It's not completely non-invasive. And you can see over here that MaxCorp has a number of interesting systems. We've got routers, Git servers, IPv6 addresses also, quite interesting, quite a modern environment. So maybe we try to, let's try to attack some of these. There might be some interesting ones to actually go after. So supposing, the bank is doing some development and, we as the hacker think that that might be something of interest. There is a Git system over here. So maybe I can go and access this Git system. This looks quite interesting. Maybe I've stolen some developer's credentials or the developer has accidentally submitted them on some open source platform before. So I've got some nice credentials and maybe, okay, I try to log in as dev user one and password, maybe something like this. All right, I'm unable to log in. Looks like my credentials didn't work. Let's take some more examples here. Maybe we take, I saw a Citrix, so maybe we take a Citrix. Oh, sorry, that was the wrong one. I'm going to the wrong site, citrix.maxcorp. And we'll just give that a second there. And since I found a Citrix system, it might be interesting for me also to try and break into that Citrix system. For those of you who use Citrix, you would know that there's been some recent vulnerabilities there as well. So I'm actually going to try to exploit that particular system. I think my Citrix, these days I get so confused by my own systems, the real ones and the decoys. So, oh yeah, here's a dev system. It's the Citrix server is not on this, it's on dev.maxcorp.tech. So this Netscaler ADC might be vulnerable. So what I'm going to try to do is I'm going to actually try that exploit which came out recently, which is a directory traversal, to try and actually break into this Citrix system. So I'm going to try to run that exploit. This is exactly what the bad guys are doing. They're doing this process of attempting to find where you've got access and then going in further, right? Trying to break in. So I've tried with legitimate credentials on the GitLab, and now I'm trying with the Citrix server, right? And I've tried both these, but the interesting thing, if you come here, is some of those hosts that I had found were actually decoys running on the internet, waiting for these targeted attacks. And I'm actually sitting in Mumbai right now in India. And you can see that both those systems, the Citrix server and the Git server, were decoy systems on my perimeter. And over here, we've immediately got a high value geolocation of this attacker. We can see attempted login, potential exploitation of Citrix ADC, and we can actually go and understand dev user one and password. So this is a really interesting way. We actually have analyzed about 500,000 of these perimeter attacks since COVID started, and we found a 25% increase in attacks against your VPN systems and remote access systems. This is one of the very common vectors that the Beagle Boys group is going to use, and they're going to try this. So one is take an inventory of your systems and consider, to detect this, you run decoys of this. The interesting thing about these decoys is they don't just respond to any random person scanning. They will respond only if someone is looking for your organization. So they don't trigger in the day like hundreds of times. They'll trigger only when there's a real targeted attack. This is a great way for you to get threat intelligence on who's targeting you. Because imagine right now, there are hundreds of people scanning the internet, but how many of them are looking for you specifically? This is a way you can use deception to actually figure out very quickly that people are looking for you and what are they trying to break in on. Our customers have seen lots of their users' credentials have been phished or compromised in another breach, and the hackers are trying credential stuffing attacks. So they find a VPN, they don't know it's a decoy, and they try to log in with those credentials, right? And then they give up the fact that these credentials are compromised. So this is one example. I'm going to come back over to our next example. So we tried one level of, sorry, press print. We tried one level of initial access. Let's now say that, let's assume our bad guys get in. Like, we're going to detect them, but let's just assume that they get in, right? So now when they get in, the next step that the bad guy has to do is he has to escalate his privilege level. Typically, most of you would have put some basic controls that your users are hopefully not running as administrators. If they are running as administrators, please jump off this webinar and immediately go fix that problem. But the next logical step is, if I break in, I want to get a higher level of privilege on the system. Typically, this means I want to get access to some domain level credentials or find some valuable internal accounts. So I'm going to give you two examples of this. What I'm going to do is I'm going to show you how these groups are trying to steal credentials. And we're going to talk about two types of credentials. We're going to talk about service accounts. Service accounts are very valuable for hackers because they typically have very high privilege levels and they typically don't expire, right? Their passwords don't expire because they're used, by applications, right? So if you don't have an inventory of your service accounts and you don't know that their passwords are extremely strong, please take that as a tip because these accounts are going to be targeted. Second is they're going to look for the user's credentials as well. So again, let's go to a live demo. In this case, what we're going to do is we are going to pretend that this Windows machine that I've got, this machine has been compromised by the Beagle Boys group. And now they want to actually escalate their privileges. Now, they would not be necessarily doing everything from a GUI perspective. I'm keeping the GUI on just because it makes it easier. If I sit and spend the whole time in the command line, it might be a bit difficult. But let's try to understand how they would operate. So let's try some sort of service account theft, right? So I'm going to start by loading some malicious code in memory. Some of you may have heard of in-memory attacks and fileless malware. So I'm going to use PowerShell here. PowerShell is used by this group extensively. They use Windows scripting and PowerShell. I'm going to use PowerShell to download some malware as PowerShell code. And instead of writing it to the disk where an antivirus can detect it, I'm going to keep that, that malicious code in memory. So I'm running that and it's actually loaded with this one PowerShell command. And now this PowerShell code gives me the ability to try an attack, which is called Kerber roasting. Kerber roasting is an attack which allows me to search for service accounts in your Active Directory and try to get their password hashes. I won't go into the technical details of how it works, but basically it's an extremely powerful attack. If you've not ever had an Active Directory security audit done, there is almost a 90% chance that your environment can be compromised using this attack. So Kerber roast, again, when I run it, you'll see a lot of output. That will be the password hashes of all the service accounts that are in Active Directory. So let's try to run this. We're operating as the bad guy. So we're running it. And you can see that we've got some, it looks pretty scary, but these are the password hashes, right? And these are the account names. So you can see we've got an account called ADM, might be admin. We've got another account called DBSVC, might be a service account for a database. It actually points to a network file server called MaxServeDB, very interesting. And we've got another called DB admin. which points to an SAP service, right? So if I was the hacker right now, I'd be very, very excited. I've got 3 really nice passwords that I would crack, and I would copy these password hashes and I would put them into a brute force cracking system. And invariably, these crack fairly fast because these are RC4 encrypted. So they're actually quite easy to crack. However, what our hacker does not know is actually some of these accounts, 2 of these accounts were decoy accounts again. And what we've done is we've created fake accounts which are Kerber roastable, so they look vulnerable. And you can see immediately that when our bad guy has tried to do this Kerber roasting attack, we have immediately detected it. So we've detected his ability to escalate his privilege level. Let's go a little bit further. We talked about 2 pieces, right? We talked about service accounts. Let's take valuable internal credentials, right? Because maybe we'll say, okay, this is too complicated for him. So instead, I'm going to take something much more straightforward. Many of our users will save passwords in the browser, right? They use their applications every day, and when they're logging into an application, they say, save this password, right? Hackers love this because it gives me the password and it gives me the place to log in also, which IP address or which host name. So I'm going to use a hacking tool called Lazan. Lazan dumps out the passwords from a bunch of different places in a Windows machine. And I'm going to tell it, okay, please go and get me all the passwords that are saved in the browser. And so it's actually run, the tool has run, and you can see that there were some Google Chrome browser passwords that were found over here. And these look very interesting: SAP info, SAP web new, and you can see I've got the password default and Batman. So if you were a hacker, what would you be doing here, right? I mean, immediately you're probably going to want to try one of these, right? So let's try and go over to one of these. And I'm going to actually try to log in. And it looks like an SAP system. I may want to compromise this, maybe log in as that Jonash user. Now, one of these is real, one of these is fake. I actually don't know which is which. So, I mean, I'm just going to try to log in. I actually don't know if I've picked the right one, but you can see immediately here again on our dashboard, we have detected his attempt to find those credentials and connect to this SAP info system. So we've got this web application attack, attempted web application access, and we can immediately see he's tried to log in as the Jonash user. So, we've already detected our bad guy 1, 2, 3 times, but let's keep going. Let's keep seeing how our bad guy will operate. I'm going to take, a slightly different approach now as the bad guy. I'm a bit worried. Maybe this bank is a bit secure. So I'm going to try to, before I do anything, I'm going to try to disable the security systems that are enabled, right? So a very common way bad guys and malware will do this is they will check for certain known security software, like endpoint security software, etc. So I'm just going to go over to my task manager. And I'm going to come over to the list of processes that are running on the system. And I'm looking for any particular process that looks like, it might be a security program, right? Because that's going to be something that, might be detecting me right now. So I just want to be a little bit careful. Now, here's an interesting one for those of you who, are familiar with software that's out there, simtray.exe. Let me just look it up. And it's C:\program file Symantec. So this is the Symantec process, right, which is actually running on the system. So the system is protected in this case, say, by a Symantec system. Now, Symantec was going to detect me, right? So I'm going to try, and I'm not going into the technicalities here. Normally, this would not work directly, but I'm just giving you the concept. I'm going to try a defense evasion task. So the next step for our bad guys after privilege escalation is defense evasion, disabling the security software. This is exactly what the Beagle Boys group will do. And we're going to do that by killing off this SIM tray. So I'm going to end it, gone away. Great. So this is great news for me because now the security software is removed and I should be able to now commence with the rest of my attacks, which might be a little bit more invasive. I may need some more malware, key logging tools, etc. So I want to actually use those particular tools. However, something interesting has happened here again. If I look here, I've got a notification that by our Jonash user on the endpoint, there was an attempt to stop a decoy process. Now, the interesting thing is this Symantec simtray.exe program was a fake process, which we had actually run on the endpoint to look as if that system was protected. So when the bad guy tried to evade the defenses by killing it, we have immediately got an indicator that he is trying to mess up with the security software. So we've detected the defense evasion. This could be used against ransomware as well. Most of the ransomware will try to stop certain programs and services. So for example, they'll try to stop applications that are running so that they can encrypt the files, so the files get unlocked. So decoy processes is a great way to catch anybody messing around with the security software and anybody trying to encrypt files, right? So again, we've got another detection of our bad guy. Let's go a little bit further. And I'm going to come back to all this just to kind of post-mortem it. So we've gone quite far into the kill chain. Now as the bad guy, I want to do some discovery. So as discovery, what might I want to do? There are a few things which I might want to do. One is, we're sitting on this endpoint. Let's find out if there are some interesting files on this endpoint itself. There might be something useful on this machine. Maybe we find some passwords or something like that. So let's come back to our endpoint. And again, I'm going to use that malicious PowerShell that I have. And what I'm going to do is I'm going to go to the users directory. And one thing that the Beagle Boys group does is they very efficiently use PowerShell and other scripts. They don't manually go through stuff. This is how an APT speeds up their attack. They use a lot of scripts to make it very efficient for them to find information. So, you might imagine that they're sitting going through manually. They're not. They actually, use tools and scripts at scale. So I'm going to replicate the same thing. I've got a little script here. Find interesting files. Okay. And I've got the script which is going to go and look on the whole disk. It's actually going to use the Windows search functionality, and it's going to find, does our Jonas user, does he have any passwords, any credentials, any interesting files that might look like I can take some information. So we're going to run the script. Very efficient way to actually get information, and it's going through his user folder, and you can see that we found some interesting things, right? There were quite a few, but the last few look very interesting to me. There's a file called passwords.csv. There's in desktop important. There's another file called passwords.txt. There's a file called secret, and there's a SAP admin RDP file. So something which might allow me to RDP to a system, remote desktop. So this is quite interesting to me. I mean, let me just try, this guy's got a password file. So I'm going to go and read that file. Let's just come back here, just clean this up a little bit. I can actually make it a lot easier to see what's going on by changing our layout so that things become a bit easier for us to see what's going on. Let's come back and let's try to read that passwords file. So that passwords file is interesting. It's got some interesting passwords, an FTP server, SAP. Looks very interesting. Maybe we try to read. There's another file which was a CSV. Maybe that's also got something. This has some other credentials. There's a router password or something over here. This looks very interesting to me as well. So maybe I'm just going to try to access this. But essentially, and I'm sure by now you're getting the hint of what's going on in the background. I need to take this back so that I can. You can see that a file decoy was accessed, opened. And not just that, the file was accessed by a suspicious process. That's very interesting. So it looks like the text file was a decoy file, and it was accessed by PowerShell.exe. The security team has got all the forensics. This cannot be a false positive. This has to be real. So why is PowerShell.exe reading this password file, right? And again, the hacker has again been detected over here, but assume that he thought that, okay, he can use this access. Maybe he wants to come and try it again. Now, the interesting thing is this is that Cisco router. So maybe he tries to log in, using those credentials. Can't log in. This is again a decoy, right? So every time he tries to access anything, in this case, I had the decoy on the internet. So you can see that, it's actually come and it's attempted to log in over the internet. I did this because my VPN is not working. Normally you wouldn't find your Cisco router hopefully sitting like that on the internet, right? So you can immediately see that I tried to log in, and that has been detected as well. So let's come back. We've now tried passwords, we've tried looking for files, we've tried a number of different things. Maybe I use that Active Directory stuff that I mentioned. So maybe I say, I want to take a look at what are the users in our domain. I think it's user, and I just want the names. So I'm just writing so I've got a list of all the users who are in my little network here. You can see that these are all the users that we've actually found. Again, what's going to happen is, because as the bad guy, I'm trying to enumerate some of these accounts are decoys. I don't know which. Maybe this Ashton account is a decoy. I don't know. But essentially, what I can find here is LDAP enumeration detected. So we can see that the DB admin account was a decoy, and the fact that I was trying to enumerate it has also been triggered, because why is someone trying to query the properties of a decoy account? So again, we've detected the guy when he's trying to find a next step. Let's take a final stand, right? Let's see the last thing our bad guy can do. Now I want to actually hack into a Swift machine. Obviously, this is something which is very specific to banking. In some cases, they may not use Swift, they may use something else, but I'm going to use Swift as an example because I think that's pretty topical. So I'm going to show you what that would look like. I've switched over to a video here because I did not have a Decoy Swift system for various reasons, but it's the exact same concept. So what I'm doing is, this time I'm going to run a port scan. Our hacker has got all the passwords, all the access, or so he thinks. Let's run a port scan and let's find what systems are on this network. So I'm running this port scan. And what's going to happen is a few interesting things. One is, because there are hundreds of decoy servers, he's just scanning a small part of the network. But immediately, we're going to find all kinds of attempts to hit and query and scan and log into these decoys which we have. So, you can see how many decoys, even in a small network that I've placed. By now, the security team, would have cut him off. But we're trying to just allow this bad guy to play a little bit, right? And we've detected everything he's doing. But let's come and see what the bad guy is seeing. He's seeing about 31 different systems on this network, and you can read through them and you can look and try to understand what could be interesting. So there are some names which immediately look interesting to me. There's a DR Oracle HR system. There is a PAM, might be privilege access, PIM and PAM. There's an exchange server. FS01 might be a file server. A really interesting one to me, which probably you guys would also notice, is SER SWFT04. So that looks like a Swift server. It's running FTP port and web. So that's also pretty accurate looking. So let's see what our bad guy does. Maybe he starts in the file server, and he finds the file server has some good file shares, and there's a finance file share. Looks like it's full of financial information. Now, the question you're probably asking yourself is, how much of this is real? So a deception system like ours is automatically creating all this fake files and all this. None of this is real. This is designed to look real, but none of it is real. It's all automatically created fake material. So I'm trying to give you the impression of how much we are giving the bad guy as a fake attack surface, right? But let's come to that Swift server. This is really what I was after. It's time for me to get my money. And so it looks like 7.1.10, right? Looks like it needs to be patched also. And I'm going to try to log in here. And I've logged into the application, and I'm going in, and maybe I'm going to go and I'm going to query something. But that particular Swift application that I actually showed you is also a decoy. This is a decoy system. So the decoy can be as interactive as you want. It could be a custom application of yours which you have. The decoy can be made to look exactly like your environment. So not just can you just stop the hacker when he tries to access, you can find out what routing code is he putting, where is he sending the money. You can get that counterintelligence information, which allows you to understand more about the threat group. And this is a very powerful part about deception. Usually other security tools, they don't give you a business context to the hack. They'll tell you, we detected something. They don't give you, who is the attribution, who is targeting me, what is the profile of the bad guy, right? Deception allows you to, get that information, in a very straightforward manner. So coming back to our slide deck, so we covered how they get initial access. We covered how they escalate privileges with things like Kerberos roasting, stealing browser credentials. We covered how they try to disable security tooling so that you can't detect them. We covered how they enumerate files, folders. We went a step further. We even enumerated the Active Directory and lateral movement. In this case, I didn't use RDP. I logged into the Swift server on web, but I could as well have logged in on to that Swift server on RDP. And then the interesting thing in a decoy deception system is the guy would get a full RDP and the security team would get a video replay. So they would be able to, instead of reading logs, they can just watch the video of what the bad guy did. So that gives you great forensic evidence of what was happening. So this is a typical attack by how the Beagle Boys group would operate. They do have some places where they'll chop and change things, but the broad flow of this attack from initial access, privilege escalation, defense evasion, discovery, and lateral movement is the same. The final step would be, are they going to encrypt something? Are they going to steal money, right? So I hope this gives you a flavor of how they are operating through the kill chain. This is a multi-step, multi-vector attack. If you notice, other than my loading that initial PowerShell script, a lot of the tools I'm using are what are called live off the land. I'm not using malware because that can be detected. I'm trying to use the built-in tools in Windows and in the operating system. I'm trying to use legitimate tools so that the security tools like the endpoint protection systems cannot detect my activity. So Maruf, I thought I'd take a quick pause here. We covered a fair amount of ground. I know it's difficult to take a very seasoned threat actor and try to make it simple, but I've tried to cover the key points, key places where you can detect them. So I thought I'd take a second, maybe if you had any thoughts on the demonstration.
Sure. Thank you, Sahir. I think this you have articulated very well, especially in the anatomy of the attack and through the kill chain. And while we are going through the presentation, we have a very very large number of audience here, close to 100 people here that we see. And so in this case, the interesting part is we have been getting quite a few questions. So I think this is now I hope this what you have explained, this has given our audience, our participants, a good understanding about what is the anatomy attack on a, especially any nation state actors, or like especially in this case, you have focused on the Beagle Boys. Now, some of the questions that I've started getting is about more about, since we are covering the deception defense perspective. So let me start going through a few questions, and let me have a shot at it, and then also let's have a look at what we are all thinking about here on the questions perspective. Now, the very first question, so right now I'm seeing is deception solution right for any banks, depending on the size, small or large perspective? Um, well, let me address this, and then Sahir, please feel free to jump in. So now, industry's perspective. So smaller size of the banks or financial organization, now what typically obviously have is may not have their own security operation center in a very focused way, but still need to find out the most dangerous attacks and within the limited budget and personnel that banks would have. Now on the other side, more mature banks might have a SOC already in place, but still they still have to be doing more with less. Now, from that perspective, the actionable alerts the deception really provides that extend the reach of any small SOC or any in that perspective, making the threat detection and investigation more efficient, as Sahir has already mentioned. And I think one of the point I think Sahir you would agree is that from the technology perspective, doesn't matter what the size of the organization is, the deception really gives a better signal to noise ratio. Over to you, Sahir, if you want to add anything on this.
Maruf, absolutely right. I like to put it this way. If you're a smaller organization and you're just getting started with threat detection, what deception will let you do is detect better threats. In other words, start very quickly from next week, not going through, the typical SOC cycle can take you, certainly a few quarters, maybe a couple of years to get mature and get everything working. Deception will let you detect better threats very quickly, which means you plug in deception, and from next month you're detecting guys of this caliber, okay, with a minimal investment. So it's a much faster way to detect more sophisticated guys, detect better threats. The second is, if you are a seasoned security organization, you have a SOC, you have a SIM, you have some controls, deception helps you detect threats better. You see the difference? One is detect better threats, the other is detect threats better. The detect threats better is use the low false positive quality of deception to make the rest of your security telemetry and use cases in your SIM very, very accurate. This is something that I see my customers doing all the time. They make the deception the real trigger on top of which they investigate alerts. And I can give you some quick case studies of this. We found that security teams were wasting almost 25% of their time. Out of every 1 hour, 15 minutes was wasted on false positives. So we give back that time to the analysts. Part one. Part two, I've had mature organizations right now, everybody's trying to save costs, reduce their SOC and SIM expenditure anywhere between 8 to 15% with deception. I had a customer just last week who told me that because I've put deception for lateral movement, I've decided that right now this year I'm not going to go and collect all my net flow logs. And those net flow logs are very voluminous. And as we all know, the SIM vendors charge by data ingest or storage or EPS. So he's saving himself hundreds of thousands of dollars just on not doing the net flow with deception. Another example on a cost optimization side is another company that I have. They're not a bank, but they're a very targeted industry. They have decided that they will not deploy EDR solutions on every system because it's a very expensive technology. So they have deception on all the endpoints, and then they put EDR on only 15% of their their environment, which are the high value critical systems. So for the mature organization who already has investments, deception can make your threat detection much more efficient, much faster, and also incidentally, which is a nice benefit, it can save you money. And these days, if you're a chief security officer and you go to your board and you say, hey, I made the threat detection program better, but I also gave you back 7 to 10% in savings in terms of things I didn't do, I think you're going to be very popular with your management.
Well said, Syed. Syed, a follow-up question I see that has come up is about the SOC perspective. Since you mentioned about SIM, is there anything you want to more elaborate, perhaps on this SIM perspective, SIM and deception, and a SOC optimization perspective? Because that's the another question that I see here is more about how deception would help in the SOC, which you already addressed. But I just thought if you want to get into more details about SOC optimization with deception.
I can try, Maruf. I'm just finding a slide that I have. So we do, and I'm happy to put out maybe on a first come first serve basis, a conversation privately with folks who are on this call separately on SOC optimization. It's an area that's very close to my heart, so I do consults for my customers. I've just found the slide. Let me just put it up. So here's the real challenge. It's a very basic challenge. The act of threat detection and response is a funnel, just like a sales funnel or a marketing funnel. And we've been doing it in a very inefficient way for the last 10 years. So essentially, what we do is we collect from multiple security tools, multiple point solutions, and multiple devices. We try to collect millions and millions of events. In fact, it's almost like a thing that how many devices have you plugged into your SIM? This quarter, I'm going to plug in 100 more, right? And the problem here is we're collecting a lot of big data, but is it good data? Is it useful? We're being charged for it, right? Because the more you collect, the more you ingest, the more you're paying. And more importantly, you're collecting all of it. But out of all these millions of events, only a fraction, right? Literally, order of magnitude less are worthwhile data, which are alerts for the analyst. Now, what we found is most of the analysts, we did a survey recently, and we found that the average SOC is receiving 5,000 alerts per day. Now, you tell me, even if you had a massive team, how will you analyze that? It's not humanly possible, which means the SOC, whether it's in-house or outsourced, is actually ignoring a huge number of those alerts because they are false positives. And maybe in there's that one, which matters. So the analysts are getting paralyzed. We're giving them more data, more devices, but they can't even handle the volume of alerts that they receive today. And once they receive those alerts, again, a fraction of those are worth investigating. And what we found, the biggest problem I found in incident response is most organizations don't know how to investigate. the SIM is supposed to be for incident and event management. Almost nobody uses it for that. So the funnel is getting clogged. It's clogged at the top because it's very complicated to collect all the information. It's clogged at the analyst level because there are too many alerts. It's clogged at the investigation level because the typical investigation is, hey, here's an alert, send it to some business owner, send it to some help desk team, wait for 2 weeks, find out what's happening, nobody replies, and then one day you find you're breached. This is very common, right? So if it's happening to you, don't feel bad. It happens to most people. And then finally, only one of these things is incident. So, something which you remediate. So essentially, you collect 1 million things to finally remediate one thing. This is a very inefficient way of doing things. It's a possible way, but let's be honest, it's failed in the industry because this funnel is getting clogged, right? The better way to do it is a perfect world where you can, you flatten the funnel. So you reduce the ingest, you take in less sources, but sources which are much more high confidence. So for example, it's great, I have people say, I want all my EDR telemetry. My next question to them is, how many of your people can actually analyze that EDR telemetry? And what was the last time that they actually analyzed and found something there? Now, if the guy replies saying, I have a threat hunted program and I have, hunt level 4 maturity, then I'm like, okay, great, amazing. You need to do that. But most organizations, they need the brilliant basics on threat detection. So take less sources, cut the ingest. The next step is you're dealing only with real alerts. Because you've taken high confidence sources, you're going to deal with the real stuff, right? Really simple places are things like PowerShell, and there are lots of different simple places. Obviously, for me, deception is one of the most high confidence sources. So you're dealing with less false positives, which means you've cut down the alert volume. And then make sure that whatever use case you have, say it's ransomware, say it's Beagle Boys, say it's Swift attacks, make sure you have the tools to get the full forensics context and you have a forensics process. For those of you who don't, on my website, smokescreen.io, there's a free endpoint investigation process. You can download that guide. It's a great starting point. It's the same guide we use for, same methodology we use for incident response. So make sure your analysts don't spend time over here. And finally, make sure you can automate the response. Many organizations are thinking about SOAR and playbooks. The thing is, if you're already starting to think about SOAR and playbooks, you've probably not thought about the beginning of the funnel. You only automate at the end, right? And only when you have the use case so tight that you don't waste time somewhere else in the funnel. It doesn't matter if your response happens in 5 milliseconds. If it took you, 2 weeks to reach that point, right? You see my point, Maruf, right? So the funnel is clogged for most organizations because they've never had the funnel concept, and they have to think about flattening the funnel. Now, flattening the funnel, there are other ways you can do it. You can add more people, add more cost. But my typical view is collect more high confidence sources so that the problem statement becomes less and less. There's less work to do, but more, better work to be done. Does that make
Very,
sense?
very well said, Sahir. I think this definitely actually makes right now deception to become an essential part of any security architecture. As you very rightfully said, organizations are looking into different tools and technologies for the defense perspective. But at this current perspective, deception, it should be viewed as a must-have component in the defense in-depth strategy perspective. So I
There's a
think
reason, Maruf, just to add to that point, there's a reason in many many regulatory frameworks are now looking at honeypots and deception. For example, in India, the Reserve Bank of India mandates in their cybersecurity guidelines that all banks have to put honeypot deception technologies. It's a mandate for threat detection.
I think that is a definitely great step because most organizations, obviously everybody's trying, but still there is really, in the industry, it shows that there is really bad internal network visibility, and deception really allows the organization to have that visibility. And I think the more customers, I mean, as you also know, and you see all the time, that they're adopting deception primarily for visibility, efficiency, and time. If we would like to summarize that perspective, they go for deception. They have the visibility into what has bypassed the other prevention systems, including the insider threat actors. Now they go for obviously efficiency because the alerts are based on the actually substantiated engagement, no dependency on signature or database lookup, and are not prone to high false positive. And because our organization typically have small number of resources in the security team, and So in the other perspective, time, deception definitely deceives and distracts the attacker. We talked about in the earlier, is that attacker dilemma, right? And now giving the organization the opportunity in real time to prevent an attack, identify, detect, and prevent an attack. So I think this is why the customers adopting more deception. And as you said, the RBI and other regular authorities are advising deception as a must-have technology for especially in the financial sector. So
Yeah.
so I think we are already a few minutes after 4. So I think this has been hopefully a great session for our participants. And from that perspective, while Sahir has already mentioned that for very selected participants, we will be providing one-on-one consultancy for if there is a need for the SOC optimization, how deception could help in your SOC strategy, where you are in the SOC journey. And at the same time, please find out if you're on the hit list. In that perspective, please feel free to request a free trial of the smokescreen solution. Drop us a line and we will provide you the 1-month free trial. And also, please feel free to drop us a line so that we can for the first come first serve basis provide the special consultancy for SOC optimization. So with
Perhaps
that,
if some people have written to me in the chat box I saw, so maybe if anybody's interested, they can just drop a line in the chat box so we just get a sense. There's a lot of people on today's webinar. I'm not sure if we'll be able to service everybody who wants it, because I've already got 10 or 11 requests here. So if anybody's interested, probably first come first serve. Maruf, we could probably handle that.
Absolutely, and we would appreciate the audience participants' interest in this case as a first come first serve basis. Then we would be able to assist in that manner. So with that, Sahir, thank you so much for participating with me in this webinar, and we'd like to thank everyone who joined here. Appreciate your time, and we definitely look forward to see you in the other futures webinars.
Thank you, Maruf. Thanks again for having me. I hope it was a good use of everyone's time. Everybody, please be safe and take care.
Thank you all.